parallel circuits. Right, this is a series circuit. Okay, you can see you've got a couple of cells attached one after the other. That's a series circuit. In a parallel circuit, they're side by side. Okay, just something interesting to notice is that if you put the cells in series, you'll end up with 4 volts. If you stick them in parallel, you'll actually get 2 volts, but they'll last a lot longer. These are the general rules surrounding parallel circuits. The current, right, the current can split. The electrons have got different choice to go through different loops. So you have 5 amps coming out of the battery at the top. You must therefore have 5 amps going into the battery at the top. If you notice, you've got 3 possible paths to go along. Along one of them you've got 1 amps, another one you've got 2 amps, so therefore you must have another 2 amps going along through the bottom one to equal 5. Make sure you understand what's going on there. Probably the best thing to do is, let's start with the one that says 5 amps on the left hand side. 5 amps is going down, 1 amp goes to the right, and therefore 4 amps is left to go downwards. And at this point 2 amps goes to the right and 2 amps goes down again. And as you can see on the other side, it rejoins again to end up with 5 amps. So make sure you know that in a parallel circuit the current can split. In series circuits they cannot. In a series circuit the current's the same all the way around. What you need to know about voltage is that for each individual loop, the voltage or potential difference picked up at the battery must equal what is dropped at each lamp. So there you can see that each lamp on example 1 has got 2 volts because they've each got their own private connection to a battery worth 2 volts. In example 2, it's actually quite interesting because if you look at, there's a loop at the top which is got a battery of 2 volts and then 2 lamps, and 1 volt has dropped off at each one. So if you add 1 volt plus 1 volt, that equals 2, and that is what has been supplied by the battery at the top. Alternatively, the electrons may decide to go around the whole outside, and there's just 1 lamp, in which case it will get a full 2 volts there, and of course that will be much brighter than the bulbs have got 1 volt because they've had to share the voltage. In resistance, there is a rule, but it's too complicated for GCSE. What you need to know is that if you keep adding things in parallel, you simply lower the resistance of the whole circuit. Really, the explanation is the electrons have got choices by which to get around, and the more choices you've got, the easier it is for the electrons to get around. So there we go. There's different paths or different loops. That is a common feature of parallel circuits. So you've got the black loop, the red loop, the green loop, and the difference. Another difference is that if one of the bulbs blows, in this case, the electricity can still get around the other ones, so the other bulbs will stay on. So that's something else to notice. In series circuits, when one bulb goes, they all go. But in parallel, if one bulb goes, the rest can stay on. And that is parallel, or that are parallel circuits.